Ham Advisory. So in this video I will present about the direct mapping. So direct mapping is a procedure used to assign each memory block in the main memory to a particular line in the cache. If a line is already filled with a memory block and a new block needs to be loaded, then the old block is discarded from the cache. Then this is a direct mapping of main memory to cache. Just like locating a word within a block, bits are taken from the main memory address to uniquely describe the line in the cache where a block can store. Okay, this one is diagram for direct memory partitioning of memory address. Direct mapping divide an address into three parts. T is a tag bits, L is line bits, and W words bits. The word bits are the least significant bits that identify the specific word within a block of memory. The line bits are the next least significant bit that identify the line of the cache in which the block is stored. The remaining bits are stored along with the block as the tag which locate the block's position in the main memory. So that's all. Thank you.
My name is Dineshwari Anna Perempuan Karupalaki. My metric number is CE200030. I am presenting associative mapping. It is also called fully associative mapping. It is also more flexible. A main memory block can be placed into any cache block position. It is also requires 12 bits for the tag to identify one of 4096 memory blocks when it is placed in the cache. Cache block 0 until block 127. Main memory block 0 until block 4095. Main memory address tag 12 word 4. Main memory address tag 12 word 4. Simultaneously compare the tag bits of the address leading 12 bits with the tag of all blocks or lines in the cache. If it matches any one, the block is in the cache. We can select the desired word from the line using the word bits. Advantages: efficient use of cache space. When a new memory block is fetched, replace existing block only when the cache is full. Disadvantage: higher implementation complexity for searching 128 tag patterns in the cache. I presenting set associative mapping. Use combination of direct and associative mapping. Memory blocks of the cache are grouped into sets. Memory blocks can be placed in any block of a specific set. Several types, which is based on the number of blocks per set. Two-way, 2 blocks per set. Four-way, 4 blocks per set. Eight-way, 8 blocks per set. Memory blocks 0, 64, 128 until 4032 mapped into cache is set 0. The memory blocks can occupy any block positions in the set block 0 or 1. 6 bits set is used to identify one of the 64 set in the cache. 4 bits word is used to identify one of the 16 words in the block. 6 bits tag is used to identify one of 64 main memory blocks in the main memory. Catch block 0 until block 127. Memory block 0 until block 4095. Main memory address tag 6 set 6 word 4. Two-way set associative mapping. Thank you, Doctor.
0077. So in this video I will talk about the virtual memory. So virtual memory is a memory management technique where secondary memory can be used as if it were a part of the main memory. Virtual memory is a common technique used in a computer operating system. Virtual memory uses both hardware and software to enable a computer to compensate for physical memory shortage, temporarily transferring data from random access memory to disk storage. So a method to have higher memory address space than what is available in physical memory. Addresses for this virtual memory is same for virtual or logical address. Then a translation mechanism must be used between logical address and physical address to get the actual data in memory. Next, how to manage virtual memory. By managing virtual memory within an OS can be straightforward, as there are default settings that determine the amount of hard drive space to allocate for virtual memory. Those settings will work for most applications and process, but there may be times when it's necessary to manually reset the amount of hard drive space allocated to virtual memory. Next, what are benefits of using virtual memory? So it can handle twice as many address as main memory. Also, it enable more application to be used at once. It's free application from managing shared memory and save user from having to add memory modules when RAM space run out. It also has increased speed when only a segment of a program is needed for execution. It has increased security because of memory isolation. It enables multiply larger applications to run simultaneously. Then locating memory is relatively inexpensive. It does not need external fragmentation, and also CPU use is effective for managing logical partition workloads. So that's all for me. Thank you.
Okay, this is the my direct math cache, and as we can see here, I've already started halfway, but I can explain it. This is just the default numbering, the cache size, memory size, and offset bits. And then this is the address, the instruction breakdown. This is the tag, this is the block, and this is the word. Okay, let's just do this again. We just generate random. Okay. first they switch, they convert it to hex numbering, and then the requested is 2F6. We will be search here, then if it's valid bit it will be obtained and analyzed. This is the diagram. If valid bit is 0, which means there is nothing that is being searched. 2F6, so there is no 2F6, and the valid bit is 0, therefore it's catch miss. Okay, it will update the tag because there is no 2F6 here, and the cache table is there's nothing there, so it will be stored there with the tag and the block. And then next is for D6. Okay, for D6 the valid bit is 1, which means there is something there, but the requested tag and the cache tag, the 46 and the previous one is different. The tag is different, 100, 1101 with 010, 1111. Therefore it is missed because it's different. And then the old one will be replaced with the new one, and then the T bit is 0, replaced with the new one, 1001101. And then the next 2BA, it will be stored here because of this. And then miss because there is nothing there, it will be stored there. Next, it is not the same, we will catch miss. And next, it will be stored, the new one will be stored. That's basically what is direct map is. It stored a certain instruction to the cache block, from cache block to memory block, and then if the data is there in the memory block and set instruction is not the same, then the old one will be replaced with the new one. But if it is the same, then it is hit rate will increase. And then for the fully associative cache, okay, for fully associative cache, it's basically the same as direct mapping. The difference being this mapping is more flexible. The main memory block can be placed into any cache block position. Okay. Yeah, it can be placed in any block. This 50F is not stored in any cache table, cache block, so it is a miss. Then it is being stored here, the first one. Okay, next. And then the next one is be stored here, Then the next one should be stored here. Yeah. And the next one should be stored the index tree. Yeah, that's basically it. It's kind of the same direct math, but it can be stored in any cache block. Then the next is two-way state, two-way set associative.